Okay, so now that you've been given an overview of what neural networks is, who Digi.no is, we're going to jump straight into actually learning how to program backpropagation, step one. So the first step is to make sure that you've clicked on this exercise, you're in backpropagation, and you want to first be able to create a simple function in Python that creates a neural net. So the first thing you're going to want to have to do is make sure you get the name right, neural net. And this neural net, it takes in two inputs, W1, and as well, the other parameter we're going to write is X, and that's for our data. So W1, X. And we're going to make sure we've got that colon over there. And we're just going to say, we're going to return W1 times X, because this is the, first of all, we're going to go through the simple equation of a line. We can then invoke that. So it's going to look like neural net 2, 3. If we pretend that we've got those data points, we can visualize it here by clicking on this visualize button. And then we can step through, going back and forward, how this neural net is defined. And here we see that W1 gets defined as 2, because we have defined W1 as 2 there. And we see that X is defined as 3. And when we return those two together, the final value is 6, because 2 times 3 is 6. And if we run it through the terminal, we have to, if we want to validate the answer from that method, we just print it out there and we see that the answer is 6. And we can submit it to make sure that we have the correct result, and that gets sent to the automatic correction feature so that we know whether or not our answer is correct or not. And it will just take a little bit there. And we see that, wow, that's too good, you just nailed it. So if we had missed out, for example, the X value, and we submit that again, and we test to see, it says, it says that we've got some syntax errors because we're printing out 2 arguments there. So let's just check again, submit. And it says return the input multiplied with the weight. So it's detected that you have missed out a parameter there. So it's identifying the correct hint. So you can also use this to give yourself hints throughout the way. So that's the first exercise. To assist with the webinar, if you want to go into this graphing file yourself, simply just make sure you've got the HTML here, and you just click here to download the tool there, and you can just extract that, and then here's an interactive graphing file, and that this video covers that as well. So just for this video, we're just going to go into the coding parts. So the next exercise says activate your neural network function with a weight W1 equal to 2. So we get some starting code over here, and if we want to have a look, we have imported NumPy. We have defined neural net here. It's got this X times W1 as before, and then we return the Z value. And then we have created a random X value through the random function, just generates a random number. And we return neural net XW1. So if we were going to run this, we would get a mistake because, well, do you see how we've defined W1? No, we have not defined W1. And the question says activate your neural network function with weight equal to W1 equal to 2. So it's just to run this W1 equal to 2. We're not going to get any mistakes here. And if we press submit, we're correct. And if we visualize that, well, it looks like this. So just move that over there. If we visualize that, we've created the neural net function. We've created X is random, and it turns out that in this random function, we get X is equal to 1.1. We go to the next one, see W1 is equal to 2. And then the neural net is, you return 2 times 1.1. You get 2.3. and that's the execution of that code. So that's then the next step. And then here, we're just going to make a plot, and we're going to plot our neural net function for a multiple number of inputs. So we can activate the neural network value with many different variables, but it'll take us a long time to calculate our real data value if we want our prediction to make a prediction. So it's easier to find out the real, the best W1 value if you can create a lot of data points, a lot of training data, and calculate it. So in this example, we're going to show you how you can take multiple data points and iterate step by step by step, and we're going to show what that plot looks like. So this is an exercise to utilize the lists given by Python, and how you can plot that list, and how you can use something called the sigmoid function to create a simple feed-forward neural network. So once again, we're not going to go too much into the theory in this video, it's just the coding. So if we're going to return a neural net given this, we want to return x times w1 plus b to get us the line equation. And if we want to, for example, also return the sigmoid, well, it would be to do this and return the sigmoid of z, because this would be the output of the line equation, and then the sigmoid of z basically normalizes that data and gives you something between 0 and 1. So that's what the sigmoid does. And here we're just defining some data points so that we can run our algorithm on multiple data points. And then here we're just going to say input w1, and we've defined b to be equal to 2. And we're plotting that. And here we're just saying we're going to save the file, and then we're going to show it. So if we run that, we should be able to generate a plot. And in this case, the plot is between 0 and 1 on the y-axis. And we can see that we're getting something based on our neural net. And if we wanted to visualize what the code was doing, just to get that bigger picture overview as well, we can plot it like here. We're going to have to remove matplotlib so that we can properly visualize it. And we'll just remove this this code over here as well, and just invoke the neural net function. Oh, and we've made a mistake there. Yeah, so of course you need to invoke it like that. And we've got 18 steps here. So we've got W1, we've got B, we've got define neural net. We've created our list there with all of these different lists. And then it looks like this. So basically this is a matrix containing these values. And then we have neural net, which takes in this, this input here. So you can see that this x is the input. That's why it's linked like that. You define what z is equal to, and z has just taken this input and then multiplied it by w1 and added 2 to it on each step. And then we return the sigmoid of z. So it goes into that function, returns that value, and you see that beautifully just shows how this sigmoid is normalizing each value and putting it into this value and this value, so on and so forth. And then it just returns it, and then the program ends. So that's what the code is doing there. That is the first chapter. So thank you for your patience for watching this. And in the next video, we're going to cover the cost function afterwards.